Hi everybody, I am Hiba Izzat. In this video I am going to explain to you what is statistics and why it's very important to understand and to study statistics for business and for economics. In order to understand the components of your system, if you are a business leader and you want to understand your customers, the behavior of your customers, what do they prefer, what offer is was perceived better than others by your customers, you need to collect data about your customers, their consumption, their preferences. If you are a politician and you want to enhance your campaign, you have to collect data about your voters. If you are a government representative and you want to know how citizens are perceiving certain regulation or a law and how do they behave, in this case you need to collect data about your citizens. Okay, so the main component, the core component in statistics is data. Data are raw and organized facts. In these facts you are trying to describe an object or an object or an event. Okay, so if you are trying to collect data about your customers, at the first beginning you need to collect data about their gender, their birth date, their address, their consumption levels. Maybe if you want to make or target high value customer, in this case you may try to collect the data about their salaries by asking them is your salary is included in the category which is less than 1000, for example, greater or between 1000 and 2000 and so on. So you are trying to categorize or to classify your customers. In this case you are trying to collect data about customers. You are trying to describe the object, in this case your customer, in order to conduct the rest of your analysis and take decisions and so on. Okay, so after collecting the data in its raw shape, in its raw status, is not so useful. You need to process this data, the collected data. You do some processing on this data. Processing may be very simple, like sorting your data. If I want to know who've got the higher grade in the class, in this case I'm going to sort all students descendingly, okay, according to their grades. So the first record or the first row will show me who got the highest grade. Or for example, if I want to know who got or who earned the lowest income, the lowest salary, so I can improve their wages, their paying rate and so on. So processing may be very simple, like ordering or sorting your data. Okay, any processing on the data is performed in order to get information. When I know who's got the first rank in my class, this is a piece of information. If I know which employee has the lowest salary, this is considered as a piece of information. Okay, after collecting my information, I can organize different data and information inside reports, in order to gain knowledge. Okay, so after we collect the data, processing them to get information, then we are trying to collect data in different sources or from different sources and trying to process this data. Okay, and then we are trying to gain knowledge, to have a higher perspective to make a decision on our system at all. Okay, any decision must be taken, it should be based on knowledge, it must be knowledge based decision. Okay, or informed decision. I can't take a decision without collecting data. I can't, if you are a business leader, you can't wake up at the morning and think the production line 1 provided us with a higher profit than the other production lines, so I will increase production, or I will move our raw materials and resources to produce more product of using production line 1. You can't take such a decision based on feelings or thoughts. You have to make a decision based on knowledge. The knowledge would be gained by collecting data, processing this data to get information. So as data is very important for our statistical analysis and to in making decision making process, we have to inspect more to our data to understand really what's data. So before we said data is a description of an object or an event, maybe an event like a seminar or something like this. You have to collect data about the number of attendees, the number of committee, or who are the committee, the date, the time expected for this seminar, and so on. Okay, so you can collect data about an event or an object. An object here we mean any item included or any unit included in your system. Okay, if we are considering a university as a system, we have many components inside this university. We have students, we have academics, we have staff, we have rooms, we have buildings, we have software applications, we have hardware applications. All of these are considered as components of the university system. So if we are considering our basic or one of our units, which is the student, and I want to collect data about my students or the students registered inside the university, we would collect data that, as we said, it's a raw and organized facts. It's like an application you fill when you enter any organization or when you try to process any procedure. Okay, so if we are trying to collect data about our students, we may have some of the characteristics or the properties that describe our student by first name and last name, for example, by birth date. Okay, so we can know later, if we process this data, we can know the age of this student. Okay, we can calculate the age of the student by subtracting the today's date and the birthday or the birth date. In this case, we can obtain the age of this student, and in this case we are transforming from data to information. So regarding again the characteristics, we may be interested in gender, address, mobile in case we want to contact our student, the level, which level, prep, MBA, whatever, department, okay, he's registered in which department, his major, and so on. Of course, the number of characteristics differ according to the purpose of collecting the data. It may be much more than this, and it can be less than that. Okay, so in data, we are interested to collect raw facts. They are just raw facts, unorganized. I am collecting whatever property I think that they would describe the object or an event inside the system. Okay. There are two types of data. Data can be structured and unstructured. For the structured data, all the items, all the descriptions, all the characteristics are inserted inside spreadsheets and databases. Okay, so spreadsheet or table. So the example here we have on screen represents structured data. In structured data, all the data type for student name, it has the same data type, it's text, and it has a definite size. Okay, sometimes we restrict the number of characters that could be entered inside the student name. For example, for the column birth date, all of the data inserted inside column birth date have the same type, which is date. Okay, and usually we restrict the format of the birth date to take the same format. Maybe it's formatted like month, day, and year. Sometimes it's formatted like day, month, then year. Sometimes the first three letters of each month is written, and so on. So if you have structured data, usually the data entry process will restrict the date, the type of the data, the size of the data, and the format. Okay, of course, it's much easier to deal with structured data. You can extract information here very easy. Okay, if I would like to calculate the age for each student, I can subtract birth date from today's date. Okay, if I want to classify or filter all females together and all males together, all what I have to do is to filter the gender column to arrange my objects with the same type or with the same gender together. Okay, also applied for the address, the level, and whatever. So also if we have a grade, for example, I can sort them ascendingly or descendingly. Okay, so processing structured data is easy. You can do whatever you want, calculations, formatting, editing, and so on data inserted inside tables and spreadsheets and databases, very easy. The other type of data is unstructured data. The example here on a screen gives us an example of unstructured data. In unstructured data, the data is not inserted inside a table, and so it's not so organized as the previous type, as the structured data. We have here a paragraph. This paragraph contains text, contains date, contains time, contains numbers, contains currency, okay, mobile number, and email. So in unstructured data, it's really very hard to analyze this type of data. Why? Because it requires much higher analysis than dealing with spreadsheet and databases. Okay, so of course examples of unstructured data can be emails, can be journal articles, can be scientific articles. Okay, any posting on Facebook, Twitter, any social media, all of these are considered as unstructured data. Unfortunately, about 80% of the data around the world is categorized as unstructured data and only 20% as structured data. So analyzing unstructured data requires more advanced techniques such as text mining, text analysis, sentiment analysis, and so on. Okay. Today you may hear a terminology called big data. Big data doesn't refer to the amount of data. Yes, it's a vast amount of data, but big data contains structured and unstructured data. And of course, big data requires more advanced techniques for the analysis and the conclusion and extracting information. So we understand what is data, information, knowledge. It's time to know what is statistics. Statistics is the science of collecting, organizing, analyzing, and interpreting data. So once we start our project by collecting this data, trying to represent the data either by inserting data inside spreadsheet, or we are going to graph the data to represent it graphically. This is considered as we are going to describe data. Okay, collecting the data from people, from different people. People can be our students, our customers, our citizens, our colleagues, whatever the subject inside our project, collecting the data, then trying to organize this data inside tables, spreadsheets, and trying to analyze. Of course, for analysis, we are starting to processing the data to transform data to information. After transforming the data to information, we are trying to represent them or organize them inside reports to interpret the results. What are the recommendations? What are the actions that should be taken in order to solve the problem, or in order to represent some phenomena, social phenomena, or business phenomena, or whatever. Because statistics is the science of dealing with data, nowadays we hear the word of data science. Okay, data science is related to any dealing with data also collection, but sometimes in the analysis process, some more sophisticated or computational models are used, such as machine learning and so on. But at the core level, dealing with data is included inside the data science. So this is why some of the statisticians nowadays are trying or are thinking that another word for statistics is data science. But you have to be very cautious about two words. Statistics is the science of dealing with data, and another word is statistic. Statistic is a single measure, okay, representing some a few data. For example, if we are trying to find the average uh, age inside women, the average people who caught corona disease, the spread, okay, the variability, whatever the measure we are trying to measure, in this case we call it a statistic. A statistic is a single measure that's used to summarize a sample data set. Okay, so if we have a sample of 200 women and we want to know their average age, in this case the mean of women age in this sample is called a statistic. Okay, it's a single measure. So statistics is the science, but a statistic is a single measure that represent some of the measures inside our data. Accordingly, there are two types of statistics. The first one is called a descriptive statistics. In this science, we are trying to describe or represent our population or the sample drawn from this population. So here we are trying to collect the data, organize this data, and try to represent the data, of course, most likely in forms of charts and graphs. Okay. The other type of statistics is inferential statistics. In this type, we are trying to draw a general conclusion from the selected sample on the overall population. So if we want to know the average age of women inside Egypt, of course Egypt today has about 100 million population. So if we want to know the average age for say for example, if we have 50% of the community represented by women, we cannot study the whole 50 million women inside Egypt. So what is usually done is that we are trying to draw a population, a sample from this population. From this sample, we are going to measure some statistic, okay, some single measures inside the sample, and we are trying to draw the same population. We say that if inside the sample, of course according to some significant measures, and we will see later how can we generalize the results of the sample on the population. If we find, for example, that the average age of women inside the sample is 60 years, we will do some calculations so we can generalize our results overall the whole population. So we will say, for example, we are 90% certain, okay, we are 90% sure that average age of women inside Egypt is 60 years. Okay, so here we are trying to broaden, to generalize the results of a sample to overall population. So here we are trying to estimate unknown population parameters. We don't know the average age of women in all the women in Egypt. Okay, we know from the collected sample, okay, but we don't know for the whole Egypt, the whole 50%, the whole 50 million women inside Egypt. But using inferential statistics, we can generalize the results, and of course this will help us to draw conclusions, and make decisions. Accordingly, this figure can show us the two branches of statistics, the descriptive statistics. In descriptive statistics, we are collecting the data and trying to describe it. In this case, we may do sample and survey, visual displays, of course, in terms of charts, different types of charts, maybe numerical summaries if we want to calculate the mean, the variance, and so on, and insert these results inside tables, or even try to represent the sample by different numerical measures. And of course we have probability models, which we will talk about them later. The second branch is making inferences from samples when we want to generalize, broaden the results and the conclusion to the whole population. And this branch includes estimating parameters, estimating the unknown population parameters, testing hypothesis, if we want to test the hypothesis that the average or age of women equals 60%. Is this true or not? In this case, we are conducting a hypothesis testing. Regression and trends. In regression, we are trying to represent our data by a straight line, trying to express our data as dependent variable, and some of the independent variables we are trying to estimate the effect of the independent variable on the dependent variable. So we are trying to get the straight line or the equation that can represent the collected data. Then we have the quality control. If we have a production line and we want to check the quality control for the produced items, we also in this case following the inferential statistics. So the question now is, why studying statistics? Why should anyone study statistics? The first, if you want to solve any problem, you should have enough information. Okay, so for example, if a manager wants to know or wants to give his employees a compensation, a commission for sales, and if he wants to make a decision and see the contribution of each employee during the last month and he found that one of the employees didn't contribute at all. Okay, so he decided to fire this employee. Taking this decision without collecting data again and try to find information about the reason why this employee didn't contribute in the last month. If he inspected and found that this employee was sick in the last month, okay, so he had a sick leave, this is why he didn't contribute. And if he took the decision of firing this employee while he was sick, of course this decision would leave negative energy and negative impact among other colleagues. If you are sick and you don't contribute to the company, in this case the company will kick you out. In this case, I think all of his colleagues wouldn't be loyal at all to this company. So You cannot take any decision without having enough information. You have to collect data, you have to transform data to information, and in this case, if you want to take a decision, it should be an informed decision to solve or to help you to solve your problem. A second reason why statistics is so important, because statistics give any company, any business organization a competitive advantage. What do we mean by competitive advantage? If a company decided to promote some of its products or services, and if the company decided to target its customer with a new promoting campaign, how would the company decide this offer would fit to which customer? In this case, the company should have data about its customers. It should classify its customers within different segments. Maybe these segments can be a demographic segmentation. The company can classify customers with respect to their age or gender. So if they have a promotion on ladies perfume, it will be useless and wasting money and time if providing such offer for men customers, for example. Or if the company wants to promote animation movie, it should target young people and children, because these are the types of customers who are really interested in animation movies. So ignoring such information, ignoring collecting data about the customers, would make the company lose money. To have money, you should earn competitive advantage in the market. You should satisfy the customers. Any company that can satisfy the needs of their customers, in this case, they would gain a higher competitive advantage among other competitors. The third importance of statistics is related to the individual employee. Inside the company, there are many problems, many barriers to run the business tasks and to accomplish every day or every week or every whatever the frequency of the tasks to reach the goals of each department. Inside each department, if one of the employees is always following data collection, transforming data into information in order to find informed solutions and suggestions based on knowledge, and suggest and offer these solutions for the problem of the department, of course, this individual employee will be very significant for the department and for the company as a whole. Instead of offering just solutions and suggestions without any knowledge, so all of these suggestions may be at once very brilliant, but once the execution of these solutions come, they would have a lot of barriers, a lot of misleading information and data and so on. So usually the employee who follows the statistics approach to find solution for the problems is considered as a significant asset, an additional asset for each department and for each company, and of course in this case he has a stable position and maybe promotion. Also at the end, don't forget reliability. If you add statistics to any your speech or your report, always you enhance the reliability of information you are intending to deliver for others. If, for example, we heard the health minister say, yes, coronavirus is very dangerous and you have to stay home. Okay? Yes, maybe some of us receive this as a critical information and some won't care because they are just words. But what if the speech is coronavirus is very dangerous? It already spread as from each 10 persons, one of the persons get coronavirus, and about 10% of all of the infected people are died. So it provides a death rate inside the speech. In this case, you would consider the speech as more reliable, and in this case people will respond to the instructions very clearly, we hope, as you are providing statistics, you are providing evidence, you are enhancing the reliability of your speech. So how statistics can serve business field? The first application of statistics is auditing. If a company know that there is a problem in some of its invoices, it would be a very tedious, very time wasting to review all the invoices. In this case, to determine what is the problem, what is the source of the problem, the best practice is to collect a sample, from the invoices, and this sample may be random sample, to check and to review the invoices to detect where is the mistake, what is the source of errors inside the invoices. The second application, of course, in marketing. Any company that is successful in its sales and marketing promotion, it has to collect data about recency, frequency, monetary or RFM formula. How recently or what recently their customers are bought the products of the service or the service of the company, how frequent these customers are, and what is the monetary value of each customer dealing with the company. This is how the company can segment their customers into high value or low value customers, and trying to fit different procedures and promotion marketing to get their customers, to gain the loyalty of their customers, or to increase the monetary level of the customers. Of course, in healthcare, healthcare is a major application for statistics in order to know what is the significant level of healing if you are following certain medication, for example, which hospital provides better health care, what is the best health policy, what are if you have some of the specializations, there is number of reduce the number of the doctors inside any specialization. All of these questions you need collect data to answer and to address them. For quality improvement, you have to select. Of course, it's very difficult to check the quality of all the produced items of certain product or service. Again, the best practice is to collect a sample. This sample may be a random sample, or maybe you will get different from different production lines, sample from different production lines, sample from different produced times during the week, for example, or something like this, to check the quality of the product. If you have a significant level of deficiency inside the product, so in this case you have a problem in the quality of your product. In medicine, again, to know if this medicine is effective and efficient, you need to collect data about the consumption of the medicine, who write prescription for this medicine, what are the side effects of the medicine, how many patients complain about this medicine or the side effects of this medicine, how many patients get better after using this medicine, and of course you have always to do significant tests and so on in order to draw and to generalize our conclusions. In operation management, if you have multiple production lines, which one makes more profit? Sometimes the numbers may give you that one of the production lines are causing more profit than the other, but when you inspect again the significance level and some of the statistical measurements that should be applied, you may find the truth is the reverse of what the numbers reveal. So you need the statistics again in order to judge which production line would gain more profit to the organization. Product warranty, you have to know that most of the companies are very smart. They would provide the product with specific years of warranty, because after certain times of tests and experiences, they found that the expected life for the product may be only 5 years. In this case, they provide warranty, product warranty for only 5 years, because they know the possibilities that a deficiency would happen in the 6th year, maybe it will increase by 50% or something like this. So always to determine how many years the product, your product, can live without deficiency or with limited probability of deficiency. You have to follow statistics. Of course, in insurance industry, if you submit your papers or any customer submit the papers to be insured, the insurance company should put many of the data inside their consideration. So if some customers submit the papers to be or to acquire health insurance, the company would collect data about the health of this person. Some of the health problems are included inside the constraint or the restricted list. If for example the customer has cancer disease, for example, or some of very fatal heart disease or something like this, after the company collected the data and calculated the odds and the possibilities that this customer will need actual compensation and so on, they may refuse the application. So in this case, to take this decision, the company needs a lot of data and information about the person, and they need a lot of statistics to calculate the odds and the possibilities of paying their part or portion of the insurance. Of course, there are some drawbacks within any field, and the statistics also has its own drawbacks. So some of the statistical pitfalls are conclusions from small samples. As we said, in inferential statistics, the main purpose is to draw a sample, try to measure some of single measures or statistics, some statistics characteristics that you think they are describing the whole population, and with some calculation you are trying to generalize the results from the sample to the whole population. Sometimes to do this process you collect really small samples. So if we want to calculate the average age of women inside Egypt, it's very tedious to draw or to broaden the conclusions of a statistic measured from a sample of 100 women. So collect a sample of 100 women to generalize the conclusion over 50 million women. It's in this case the sample is very, very small. Sometimes collecting or trying to generalize the conclusion from non-random samples. If for example the sample for easiness, you collect the sample from your colleagues, so in this case it's not random. You have some certain number of men and women inside the class, and if for example you want to see the number of voters for certain candidate, presidential candidate and so on, maybe in this case you are targeting all people who have the same education level. So in this case it's not random. Your sample is not representing the population, it only represents some of high level educated students, and you are trying to broaden the results of this sample on the overall population, which contain maybe ignorant people, maybe students, young people, elderly people and so on. So in this case you are trying to draw conclusions from non-random sample to broaden the results on the overall population. Also, sometimes the researcher has poor survey methods. For example, maybe the questionnaire written for the purpose of data collection is written in a very poor way, or written in a language that is very difficult for other people, other less educated people to understand, or maybe the question can be understood by other meanings. So in this case we say that it's a poor survey method, because the questionnaire, the tool that used to collect the data, has many confusion or many grammatical errors or many mistakes. In this case we suspect the tool originally used to collect the data. Sometimes the researcher assume a causal link. For example, if we say that divorce level is increased after financial crisis happened in 2008, and the results show that there is an increase, so the researcher drew a result that due to the financial crisis or financial hardship, the rate of divorce is increased. Sometimes this conclusion, maybe the numbers show that yes, the financial crisis affected the divorce level, but this is only if we are following numerical conclusion. If we pay a lot of inspection, if we inspect our situation more closely, you may find that the divorce rate is really increasing before the financial crisis. So it's the increasing is only a continuous of the trend, the continuing trend. The main conclusion, divorce rate is continuously increasing. Okay, it's not related to the financial crisis, but the divorce rate is really increasing before the financial crisis, and this trend is continue. So it's you are trying to relate the divorce rate to financial crisis, which is not true. So sometimes the numbers may support this conclusion, but if you inspect closely the situation, you will find that this conclusion is not true. Also, sometimes it's wrong to generalize the result to individuals. For example, if we are saying that men is or are taller than women, this statement is not true. Why? Because there are many women who are really taller than many men. So what is true, that is to say, on average, men are taller than women. So in generalizing, in drawing the conclusion obtained from sample to the overall population, you have to be very cautious. You have to see what are really the generalization between the population and the sample. The final statistical pitfall is maybe sometimes happen unconscious bias. The researcher may make mistakes while he or she is collecting the data without any consciousness to mislead the results. Maybe the biasness happen while collecting the sample. The sample is not random or is not representing the real population. Sometimes the biasness happen while writing the questionnaire. Maybe the question will lead the interviewee into another way than other than the question is supposed to measure. So sometimes there is biasness and it's really unconscious. So this also will lead to misleading conclusions or misleading results. All of these pitfalls happens, and all of them may happen at any sample. This is why any statistician, any researcher must be very cautious about these common mistakes. Thank you for watching this video.